Hello and welcome everybody. My name is Matt Piper. I'm the Global Director for Industry Solutions for Utilities and AEC at Esri. Thank you for taking the time to join us today. This is the second webinar in the Utility Network webinar series. This webinar is on the business value of the ArcGIS Utility Network. We had a fantastic attendance for the first webinar, which was on the 7 steps to getting started with the ArcGIS Utility Network. And early in August, we will run the final webinar in this series, which is on migrating and implementing the ArcGIS Utility Network. If for some reason you missed any of these webinars, the recording will be made available after the series. We have over 2,200 people registered today. And as always, we want to ensure that any questions you have get answered. In the middle of your screen, there is a chat option. Please write any of these questions you have as we go along. And we will get to them either during the webinar or afterwards during a Q&A document. As I mentioned earlier, this webinar is being recorded and the recordings will be made available at the end of the series. I've already introduced myself, but I'd like to take the opportunity to welcome our other speakers. We are very fortunate to have the directors for several of our industries join us today to share their experience and their thought leadership. Please welcome Pat Hull and Bill Meehan, who are industry directors for Electric Utility Solutions, and Tom Coolidge, who is an industry director for Gas and Pipeline Solutions. Welcome, gents. I'm really looking forward to today's discussions. We have a lot of content to get through in today's 1-hour webinar, so let's take a quick look at the agenda. Bill and Pat will take us through their understanding and definitions of business value and KPIs. Bill will then discuss some of the common challenges that are being faced by utilities and telecommunications around the world. Tom will then refresh us on what the utility network is and why ArcGIS, including ArcGIS Utility Network, is so important to your organization. I will then take us through demonstrations on the foundational capabilities before we each walk through some of the common workflows within your organization and how the ArcGIS Utility Network is enabling digital transformation. And then we'll recap and look at what's next. Well, let's get straight into it. It's my pleasure now to welcome Bill and Pat to discuss business values and KPIs.
Thanks, Matt. So utilities and telecoms measure success by balancing the needs of their 4 major stakeholders. They form the basis for the key performance indicators, or KPIs. The first is the shareholder. They require the company to perform well financially. The major KPIs include revenue, capital spending, or CapEx. This also includes operation expenses, or OpEx. The true measure of financial success is profit, or the difference between revenue and costs. Contributing factors include cost of materials, labor, benefits, contractors, business continuity, cybersecurity, and many other costs. So customers also require good service. KPIs include, of course, reliability of service. This is measured in the frequency and the duration of outages. Another important customer KPI is the time that it takes to obtain a connection for new service, or more recently for an electric utility, the time to obtain approval to connect a solar system. Customer satisfaction survey scores are carefully measured by corporate executives and are critical KPIs. Employees demand and expect a safe working environment. They also expect the proper tools and training. KPIs include numbers of accidents reported to the government, the measure of job satisfaction, and how empowered they are. Finally, the community needs companies to perform legally, of course. The community is represented by regulators. KPIs include the number of fines imposed, meeting standards of compliance. Even aesthetic violations can be measured. To fully appreciate the business value, it's necessary to consider the positive impact of the utility network on the utility and the telecoms key performance indicators. You want to follow up, Pat, please?
Sure, Bill. Thank you. Organizations regularly undergo efforts to add value for their customers or for the organization itself. They're trying to address a specific business problem and influence one or more of those KPIs. Any business value discussion has a specific outcome in mind, and with that associated benefits. In today's environments, companies have very specific goals in the areas that Bill talked about. Any effort to create value results from an investment of time and money, and decision makers have to choose wisely to limit their exposure. Projects are then classified by the time frame for return on investment. They may make an immediate tactical adjustment or may be more strategic for long-term values. Longer-term value might position the company for where they desire to be in, say, 5 years. No discussion of opportunity is complete without risk. What are the risks in change? What are the risks of not making a change? And what is the lost opportunity cost of not moving ahead? You see goals captured in companies' mission statements along with their pathways to value. Competing proposals to add business value are defined and quantified. The potential upside must be considered against the downside risks, and KPIs measure the performance in those key areas. They do vary somewhat by region and industry, but they all strive to increase value. This effort to create business value is to improve a process, a service, or a product in ways that align to the business strategies and initiatives. This is how companies achieve their strategic objectives and deliver customer value while solving their business challenges.
Thanks, Pat. I really like what you just said. From my experience, it doesn't really matter how good of an idea you have or what technology you use. To be successful and to be sticky, it really needs to align with a business strategy or their strategic roadmap. Another key point is that it needs to be aligned to solving some sort of business problem or challenge. Now, Bill, you've worked closely with many companies around the globe. What are you seeing in this space as some of the key challenges that utilities and telecoms are facing?
Sure. Well, over the next 5 years, utilities and telecoms will probably see more changes than they've had in the past 50 years. I really believe that. And I know customer demands are changing. There'll be increased competition in both the gas and the electricity market from the distributed energy resources like solar, wind, and energy storage. Networks are having to shift to adjust to new loads caused by electric utility vehicles or electric vehicles, EVs. Customers are demanding a higher engagement and have the choice on how to engage with the market through things like demand response. Regulators are increasing pressure for compliance to adhere to the latest best practices and safety compliance. Network operators are needing real-time awareness. The need to operate within a modern network increases. Assets continue to age while demands increase. Climate change and extreme weather patterns continue to create havoc with the infrastructure. Utilities and telecoms are facing more and more emergencies. These challenges demand new technologies. The utility network together with ArcGIS can help. So what do you think? Joe, why don't you kick off a poll and find out what the participants think?
Great. Hey, yeah, go ahead, Bill. Go ahead and jump right into this poll. So the question is, what is the biggest business challenge your organization is trying to solve? So go ahead and please select one of these that most applies to you. Is it aging assets, regulations, operating a modern network, emergency management, or changing customer demands? So I see some of the questions are coming in. We'll give it a few more seconds. I'm going to go ahead and close the poll and let's look at the results.
So Joe, that's pretty interesting. So operating a modern network seems like that's the biggest, won the award for the biggest challenge. And I would tend to agree with that because, things like EVs and DERs and the struggles that telcos have with building out all these IoT networks, that's going to be a real challenge for everyone. So Tom, do you want to take it over from here?
Okay, let's start our look at the business value of the ArcGIS utility network with some important context about the utility network itself that needs to always be remembered. While we'll mention the utility network a lot, it needs emphasized that the utility network is a capability of the ArcGIS platform, not something separate from it. Think about it as one of many parts that combine to make ArcGIS a platform. And keep in mind the 5 aspects of the utility network in ArcGIS that you see on this slide. Also, remember that the utility network information model is purpose-built for utilities and telecommunications companies. It's specific to those industries for which it is intended, and it results from significant R&D and was developed in collaboration with the global utilities and telecommunications community. With that, I turn you over to my colleagues Matt and Pat for a closer look at some of these.
Thanks, Tom. Look, I really hope that that gave some additional context to what the utility network is, especially if you'd not seen the first webinar. This was covered off in the first webinar, as was this graphic on the screen, and it really gave some context on what the ArcGIS utility network is. Now, Pat, can you continue this conversation and take us through your perspective on the fundamentals of the utility network? And I'm going to discuss some of these capabilities in a little bit more detail. But first, over to you, Pat.
Certainly. Utilities around the world asked for solutions to their challenges. As Tom mentioned, the Esri utility network capability is the result of tremendous research and development in direct response to those requests. It solves problems for agencies in all the industries that we've mentioned. At the core, the utility network is an information model. Its characteristics are themselves very useful, and they also unlock additional high-value capabilities within the ArcGIS platform. Now, this is not a technical presentation, but it is worthwhile to pause here for a moment and take a high-level view of the fundamentals. You can think of these fundamentals in three buckets: advanced network modeling capabilities, state-of-the-art visualization and analytics, and the underlying system architecture and the security that it provides. Together, these form the foundation of a truly modern GIS that is one that stores information, uncovers business intelligence, and communicates those insights to all of the stakeholders in a role-based manner. Matt, can you start us off with a look at some of the modeling capability?
Thanks, Pat. I thought it'd help if we started today with walking through some short, sharp videos of what the foundations that you discussed earlier are. By doing so, I think it will help later when we get into the business workflows and values. The first topic we will cover is structure networks. Structure networks model the various types of structure components that support the three types of utility features. Structure lines, for example, trenches and duct banks. Structure junctions, which include things like poles and manholes. And structure boundaries for things like substation boundaries or switchgear enclosures. Structural network assets are also associated with utility assets. In addition, a structured network does not have any resources such as water or electricity flowing through it, but they can contain or be attached to other utility features. If you look on the screen here, you can see that a pole has been selected, and on the right-hand side, the structural attachments are selected. In this case, it is a medium voltage pole. Down below, we can also see that there are associations to this structure. This pole has two structural associations, a medium voltage line, and a transformer bank. Structural networks allow you to manage and maintain all the structural assets in one place, even though they are supporting assets from different domains. The next topic we'll talk about is domain networks. Domain networks contain the features through which your resource is delivered, and these could be delivered across either electric, gas, water, telco, or district heating. There are 5 types of features in a domain network. There's lines, through which a resource flows, for example, conductors, pipes, or cables. Devices that control the flow of that resource, such as breakers, valves, transformers, or pumps. There's junctions, which are places where features are connected. Assemblies, which represent a collection of lines, junctions, and devices, for example, a switch bank or a transformer bay. And finally, the subnetwork lines that define the extent of resource flow. And these are typically represented as circuits, feeder, or pressure zones. Domain networks allow you to organize and model large, logically different sections of your network. And it is also worth noting you can have more than one domain. The next topic is network tiers. Network tiers are used to organize a network hierarchy in a domain network. Network tiers typically represent ranges of pressure, voltage, or other logical groupings of the delivery of resources to the network. In this electric domain network, there can be multiple tiers defined based on the voltage the assets are dealing with. For example, the distribution tier, the subtransmission, and the transmission. Network tiers allow you to model, view, and analyze the entire network in one place. And this can be done from the generator all the way through to the customer, which is critical when managing a modern network. The next topic is subnetwork lines. A subnetwork line is generally defined as a connected subportion of the network. These will be circuits in electric and pressure systems and or isolation zones within gas or water. If you look at this map, each subnetwork is represented by a different color. Subnetworks are important to a utility because they give operations personal situation awareness of how the network is configured and connected. In addition, the subnetworks provide capabilities to aggregate and query to return key operational information like device counts, network demand, and network load. These subnetworks are maintained by the utility network based on the asset details of the other layers. Subnetworks provide an operational view of the network with dynamic analysis and tracing capabilities. Let's now look at asset groups and asset types. All the network assets can be captured in the utility network in one of the 8 feature layers. There's 3 structural network layers and 5 domain network layers. All the assets in the utility network get 2 mandatory attributes. The first is asset groups, which are the major classification layer. This includes asset groups like high voltage switchgear and HV arresters. On the left-hand side, for example, if you go into the electric device domain, you can expand it out to see other devices, including high voltage switchgear and a medium voltage transformer. Under the transformer is the list of asset types. Asset types are the minor classification, which include asset types like overhead single-phase and pad-mounted 3-phase transformers. It is worth noting that network rules are designed at the asset type level. Asset groups and asset types provide a classification on all the features in a utility system. These attributes allow you to define and categorize your network assets. Finally, we will discuss terminals. With the utility network, you can model devices to a high degree of realism with terminals on devices. Terminals are not features and do not appear on the map. They are logical connection locations on devices that allow you to control how other features connect to the device. Certain network rule types can be defined at the terminal level. Let's look at the example on the screen. You can see we have a medium voltage conductor, a transformer bank, a line, and a pole. But you can see there are no lines joining these features together. Now, as before, this is because these connections are shown using associations. By selecting associations, the connections are now visible. It is clear that the high side of the transformer is connected to the line end, and the low side is connected to the low voltage conductor. Devices in the field have a defined location or ports from which resources such as electricity and water flow in and out. A utility network allows you to optionally model these ports with terminals on device features. Terminal capability allows modeling at a very high level of detail with inherent validation rules. That covers off the advanced modeling capabilities of the utility network. And I know we just went through a lot of content. And the next section I would like to cover is on visualization and analytics. And this will include 3 parts: containments, tracing, and diagrams. I used our electric network to demonstrate the last video suite, so I'm going to use our water network for this one. So let's get started with containments. Containments allow you to model features inside other features. The intent is to reduce map clutter and allow you to model assets in more detail. As you can see from this view, most features are hidden. However, if we zoom in a little more and enter the containment, we begin to see all the other assets as before. Here we can see a pump, valve, and meter, and as you can see, the meter is not connected. But as we did before, this connection can be shown inside containment as well by just viewing the associations. Containments allow you to visualize inside plan to better represent the asset features. It provides a real model of connectivity that can be traced. That leads us straight into discussing tracing. Tracing allows you to validate connectivity from and to defined points. ArcGIS Pro comes with 8 out-of-the-box trace options to meet your business needs. For this discussion, I'll be talking about the isolation trace. First, you need to select a starting point. The run isolation trace will begin. Then run the trace. The trace network is highlighted in light blue. Also note that the isolation trace has identified the 4 valves that need to be isolated if a fault occurred at this starting point. Tracing allows you to analyze the paths in your network. A trace returns features based on traversability or connectivity based on a given start point. Tracing can be used to propagate to network diagrams. Let's now talk about network diagrams. Diagrams are a symbolic representation of the network. They are often used to represent a simplified view of the network that are often not spatially accurate. Let's look at a simple single line diagram next to a map view. They look similar, but let's now change it to be a main tree line view. This looks a lot closer to what is seen inside operations or printed out in the field trucks. Both the map and diagram are interactive, and a selection in one is reflected in the other, as you can see here by selecting the hydrant. If we look at the tree view, we can see that we select the hydrant, and then we're able to apply that to the map view. Diagrams explain the network structure and how it operates in a simplified view. This capability replaces paper single-line operating schematics and keeps the network up to date, which is critical for operations of the utility and telecoms.
At the core of ArcGIS is a services-based architecture. With that architecture comes several inherent benefits, including greater scalability and performance, enabling more robust integrations with other systems, and supporting both on-premise and cloud computing infrastructures. Those are essential characteristics necessary to support the information technology needs of a modern utility. Your geospatial data is secure within ArcGIS. What's more, all ArcGIS apps and developer SDKs use these secure REST APIs. What is also important to note is that the ArcGIS utility network is not only secure, but it provides additional controls through user types that not only control what a user can see, who has access to it, but it also controls what a user can do. For the next section, I'll be inviting all of our speakers as we work through and discuss how to unlock this business value through workflows using the ArcGIS utility network. Tom, can you get us underway?
Sure can, Matt. Thank you very much. With those fundamentals in mind, it's easy to see how the utility network can more fully unlock the capabilities of the ArcGIS platform to deliver further business value in many utility and telecommunications company business areas. This slide highlights 5 of them. 4 are shown as groups with selected workflows indicated by bullet points: design and engineering, asset management, operations management, and customer care. And in the upper right, you see a number of emerging technologies. These include 3D, hub, indoors, artificial intelligence and machine learning, and imagery and drones. Together, these can be thought of as a 5th group. In the remainder of our time today, we're going to look more closely at the 4 grouped business areas. But before we begin that, let's take a second poll to get your thoughts on all 5. Joe, will you put up our second poll?
Yes, no problem, Tom. So here is the second poll, everyone. After hearing what Tom just went over on the previous slide, we'd like to know, in which area do you feel the ArcGIS utility network will benefit your organization the most? Is it design and engineering, asset management, operations management, customer care, or, as Tom said, the 5th one, the emerging technologies? Looks like they're starting to slow down. Give it a few more seconds, and let's go ahead and close it and show the results.
The envelope, please. Well, there you have it. Asset management at 41% takes the top spot, followed fairly closely by operations management, 9 percentage points behind at 32%. And then interestingly, there's only one more than double digits, design and engineering at 21. Very, very interesting. Okay, to start our look at selected workflows, please welcome my colleague, Bill Meehan. Bill?
Hey, thanks, Tom. So one of the most significant features of the utility network, especially in design and engineering, is this notion of web services. This creates immediate project collaboration. That means that designs created in the utility network are available across the network, not a download nor an export, but a direct connection to web and mobile apps for communication of the field, to managers, and to corporate executives. This example shows multiple gas design projects in various stages of engineering, design, construction, and commissioning. Even financial information is included. Here we can see a single project, or by simply clicking a button, you can see multiple projects or multiple versions in different phases of planning, engineering, and design or construction. And here we see various aspects of this design displayed in different colors. So ArcGIS Utility Network creates transparency of the project design from planning to energization. One view of the design is available on any device, anytime, for a complete project collaboration. And that's really, really important to do. So the trend today in design is visualizing in 3D. So building an electric transmission, I was involved in transmission for years, that can be a really tough sell. Shown here is a case of visualizing a proposed electric transmission line. Note that realistic transmission towers and lines can be visualized. You can set conductor alignment, insulator type, 3D catenaries, and support structures. Now, well before the design process begins, utilities can bring those designs to the public. Altering these designs in the early stages of that's a simple matter. But after detailed design, changes can be costly. Aside from the community engagement, the 3D views provide engineers analytics on factors such as river crossings and clearances. And distribution lines can be visualized as well. Here we see how engineers can better understand the impact of their designs on the rest of the community. This is a nice view of the proposed distribution line. Most utilities have not included their complex substations in their GIS. Here we see the representation of a substation, first as a 2D view, and now we're seeing it as a full 3D representation. It's not just an image, but includes all of the features so that engineers can trace through the substation. Not including substations in GIS is a major gap in asset management, system analysis, and visualization. Water and gas underground services can now be visualized in 3D using this clever trench design. Now it becomes a simple matter to employ like augmented reality. After the trench is filled in, we can see location of underground pipes. That's really, really interesting. Another critical feature of the utility network and associated ArcGIS capabilities is to model assets in a precise, realistic manner. In this demonstration, the designer captured the water system in Civil 3D, Revit, and CAD files. They were imported directly into the utility network. The idea is to attach a new water service to this building, which was also imported from AutoCAD and AutoCAD BIM 360. The data in GIS includes all of the attributes of the original CAD design, but placed in a precise location in GIS. Now it can be traced directly in the utility network. Changes to the AutoCAD design are also reflected automatically in the network. So let's move on to advanced world modeling. One of the most exciting new features of the utility network is called non-spatial objects. This telecom design illustrates how individual strands of fiber inside a fiber cable can be treated as actually GIS objects, but their location is inherited by the fiber cable. Yet each fiber cable can be traced. Notice that we can trace a fiber cable from the home all the way to the correct port. In addition, the system can create a schematic representation of that trace. So real-world modeling of assets with a large amount of features that share the same geographical space is made possible in the utility network. So let's just talk about the capabilities and of the utility network in relationship to the design and engineering workflow. The utility network gives customers real-world modeling of their facilities. This is critical for accurate designs. Matt demoed this notion of structures. Structure systems such as trenches, vaults, and manholes, they must be part of the overall designs. And then 3D visualization shows realistic views of the proposed design, like we showed in the transmission example. It uncovers it uncovers hidden hazards and interferences that 2D just misses. And schematic views provide simple to understand connectivity. We saw earlier how designs are created on the fly from the geographic view. This makes it simple to exchange those models with analytic and business intelligence systems. And data validation is critical for accurate designs. So let's talk about the benefits. We often hear that the GIS is a single source of the truth. Yet, if structured networks or metering stations or telecom ports are modeled in standalone systems, then the GIS model is incomplete. This creates an analysis and insight gap and makes data exchange with real-time systems such as SCADA or ADMS, which stands for Advanced Distribution Management System. It makes it awkward. The utility network makes that exchange simple and clean. The utility network provides direct connection to all aspects of the organization immediately. It takes its cue from social media platforms, the ability to directly connect to the web, mobile devices, and consume CAD models transforms design and engineering from, I like this term, it transforms from a largely drawn out drawing process to a real-time collaborative platform. That's a real key. The utility network optimizes design, 3D, direct connection with the field, consuming web service, and saves material and labor costs. The designs can be adjusted in real time to calm regulators and citizens. As Matt pointed out earlier, editing has built-in rules that prevent errors from the start. When designs are accurate, as-built changes are fewer. As-builts happen in real time. This eliminates costly backlogs of unposted work orders. Finally, great designs create safer projects, reducing accidents. Great tools provide a morale boost for all employees. Okay, so let's get to the KPIs. So the business value, KPIs, lower CapEx, fewer accidents, fewer updates, lower labor costs, fewer as-builts, higher quality designs at a lower cost. Better designs support operations personnel as well. So Pat, show us the business value of the utility network for operations. Take it over, Pat.
Love to, Bill, thank you. Let's examine operations to see how ArcGIS helps. I'm going to look at reliability and workforce efficiency, but of course, safety first. When I worked at the utility, many accidents that I investigated occurred when employees had unclear or stale paper-based processes and information. Utility networks help bring real-time information to the field. For example, these vehicle locations from AVL are live data feeds integrated with the network. We saw this pump station earlier. Now we have added SCADA data to the map, showing pump flow rates, pressure, and even historical data for comparison. This gives both the control room and the field additional awareness of the operational parameters of the system. Anytime, even for alerts, the same view is available in the office or in the mobile device on the right. The alert from a sensor is shown to all users, and it's easy to zoom in for as much detail as needed, collect new data, and share it with the organization. ArcGIS Utility Network delivers the same situational awareness to the control room and the field, improving safety. Reliability is a key concern for water, gas, electric, district heating, and telecommunications. Service interruptions and emergencies, they happen every day. The first task is to understand the scope and impact of any unplanned event. Then the team must isolate the problem and restore service to as many customers as quickly as possible. This requires examining the network to find isolation points and restoration options. For dangerous commodities like electricity, blocking the correct assets to stop the flow is also important in terms of safety. Here, a crew uses mobile network functions to respond to a dangerous situation where energized wires are down. Using the network, they determine they must open this fuse to isolate the danger. Their action creates an unplanned interruption to some number of customers. That triggers reporting requirements and the need to prioritize. By tracing downstream from this fuse, ArcGIS analyzes the affected portion of the network. It reports all of the equipment, the critical infrastructure, and customers that are out of service. In this particular case, 149 residential customers. ArcGIS Utility Network enables operations to understand, respond to, and communicate about service interruptions, improving reliability. Tom talked about unlocking the value of the ArcGIS platform, and workforce efficiency may hold the most immediate monetary value. As we've seen recently with COVID-19, dashboards are key to understanding. ArcGIS supports wonderful dashboards about what is happening on the system and with the operations staff. For effectiveness, work must be related to network assets, where we can factor in criticality and regulatory requirements all around location. ArcGIS captures fine, real-world detail like never before and brings in other data with the power of location. That opens up a world of analytics to optimize operations activities to get the most out of every dollar. Subnetworks provide very rich data for analysis. They reflect the way that most agencies manage operations activities like troubleshooting, inspections, and even their service levels. Here, statistics by water pressure zone are analyzed in ArcGIS Insights. The cards are all linked for easy analysis by operations employees. Operations personnel want to get the job done. With mobile real-time information on their device, they have the right information related to their work. When they make the updates, they capture the information once at the source, and it's done. It connects operations activities to the network with analytics and superior planning, and that promotes efficiency. Well, we've seen a number of capabilities that go directly to operations workflows, from scheduling and doing the work safely to optimization. If I had to sum it up, I would say network management in ArcGIS accumulates understanding for operations. When you pull together the work, the people, real-time data, and consider them in light of the network, you get a complete operational picture with everything you need to run your system well today and into the future. Now, those capabilities deliver valuable benefits to the organization. When the worker in the field has the exact same information as the dispatcher, they will be safer. Workers that have access to real-time sensor data and analytics to aid them in things like service restoration, they will be more efficient. Network analytics grant you the opportunity to tune your budgets and supplemental requests, to look at capital improvements and maintenance costs, to know what you spend and where, and make sure that they have maximum effect towards those business goals that we talked about. These forces impact KPIs. By reducing reliance on out-of-date information and improving accuracy, injury rates should drop. A realistic model of the network, outage analytics, crew locations, and inputs of things like weather data, they all work to improve reliability measures, both around frequency and occurrence duration. With greater efficiency, fewer truck rolls, O&M expense per customer could be reduced, or the same dollars could go further to improve other KPIs, such as reliability. Now, GIS is often the best model of the network. It frequently feeds into other analysis programs. Better data and understanding should result in greater system utilization and reduced losses. I hope that this stimulates some really great questions. Matt, if you're ready, what are your thoughts on asset management?
Thanks, Patrick. Really good wrap up of so far the design and engineering workflows and the operations. Now, both of those have a tie to asset management, and as we saw in the poll, it's a point that a lot of people are interested in. So I'm going to talk through three main components: data management, engineering and governance, and then advancing some of the capabilities that you can do with modern asset management processes. I'm going to start it by talking about data management. Now, the data management for utilities It's not the sexiest topic to talk about, but it's always an issue. What's really great about the utility network is this validation of rules. So if you're looking at the screen at the moment, you can see that the network rules validate the design and the data capture based on predefined rules and logic. If you follow on the screen here, you can see that the mouse is hovering over and you can see that it wants to click, it wants to attach. That's indicating that a connection of that medium, that pad mount transformer on the underground network is allowed. But at the top, on the overhead network, it's not allowed. So it's validating the design at the point of entry. Now, if we did attach that asset, you can see that it creates a data area that then needs to be validated. Now that validation does all the network connectivity and topology validation to make sure that everything that we put in that logic is actually adhered to. If we look on the right-hand side now, we're actually opening up the attributes of that asset. So you can go down and you can actually change the attributes. And if you input a wrong attribute, it's actually error messaging and saying you can't input bad data. So the ArcGIS utility network enforces your business rules and that network logic to ensure your data quality is improved and then maintained. The second thing I want to talk about is engineering and governance. Now, this is something I'm very passionate about. Too many utilities talk about asset management, but they don't even know how many assets they have, let alone where they are. The sub-network management allows you to aggregate your reporting and get counts very quickly, very easily, which makes a lot of your reporting a lot easier. Simple dashboard example here. There's 8,300 poles on the map. There's 235 valves. Using the asset grouping and asset types that I spoke about earlier, you can easily visualize and report on this. And you can integrate it with other systems and bring in their data. An example here is bringing in last inspection date or bringing in the expected life expectancies from some of the nameplate attributes. You can then visualize this data, you can provide additional insights, and you can actually bring in additional maintenance plans or changing priorities. An example of this is health indexing. Knowing your asset's age, its condition, its failure rates, you can start plotting and visualizing what's the health index of my assets. You then extend it with some of these other data sets. So the utility network provides insights to managing these assets, and location technology extends that capability. So when we talk about advancing that capability and taking that one step further, a lot of advancement in the last couple of years has happened in the drone space. Drone imagery and data capture is advancing modern asset management. An example here is a flight that's been integrated through our drone flight planning tool. You can see here that the flight plan is mapped. Every blue dot is some of the imagery that's available. You can select on this high quality imagery, zoom into the assets, see if there's any failures on it. You can also pan around and see, okay, is there any other non-physical related, so external factors that are impacting your assets? In this case, it's a couple of birds' nests up on the poles. So the image capture, classification, and change detection is really advancing our technology, but it's integrating in with LiDAR, point cloud data, feature extraction tools. So if you look at something simple like vegetation management and corridor maintenance, you can find the hotspots. But then we really push it and start bringing that information and creating this true 3D digital walkthroughs of our assets. So this is integrating all that data together and bringing in that vegetation encroachment. We're also bringing in and understanding what is the sag and sway analysis of our network, bringing in that holistic view of our assets and integrating it with all the other data sets. So the ArcGIS utility network improves those foundational asset management techniques, but it also unlocks many other advancing technologies. So that was a very quick run through on some of the asset management principles. We're going to talk you through now quickly some of the capabilities that we see. One of the big things we just touched on was data quality. Now, I cannot tell you how many times I've heard from people that our field crews have been out and captured this information 20 times that it's never made it back into the system. Utility network is mobile enabled, and you take the data out to the field, they see the most current data that's in the system, they update it, it goes directly back into the system. Not only is that happening, it's validating on site. It's ensuring that what you are inputting is valid and accurate and it can be entered. It is connecting the right type of assets to your business logic and your business rules. That really can't be understated in how you start driving some of the data quality improvements that utilities are always saying they can't get on top of. Another big thing here is the asset lifecycle management and the moving into this concept of moving from time-based maintenance into reliability center maintenance into those financially optimized maintenance programs. If we look at the benefits, when we start looking at these capabilities, being able to visualize those vulnerabilities, being able to monitor those conditions that I showed on that dashboard, being able to improve those inspections and maintenance programs and being actually validate those by managing your risk or your financial assessments to optimize. How do you align your maintenance programs with your CapEx programs? How do you have less rolling trucks so you go out and do it once? How do you not go out and replace a pole today that you've only replaced a couple of months ago because your data quality wasn't up to date? We look at KPIs. The big one here is reduced lost time. Rolling trucks out to go do work, go do maintenance on a pole that was replaced last week, going out to look for assets that no longer exist, effectively running your business based upon bad data. This results in a lot of lost time for your mobile workforce. Another big challenge here is regulatory reporting or regulations and compliance. Asset management is critical. We have ISO 55000 standards that we try to adhere our best practice. The business rules, the logic, the systems integration. The utility network is a key enabler to help you move to those best practices and ISO 55000 standards. Being able to analyze your network, understand the health, being able to track your mean time to failures, mean time to repairs, are all critical indicators on how you can start driving and improving some of those common KPIs within your asset management framework. So I think that's it for me, Tom. I'm going to pass it over to you, and if you could take us through now the customer care workflow.
Sure, thanks, Matt, will do. Let's start with serviceability. Customer care and utility and telecommunications company success go hand in hand. That is why those enterprises place such a high priority on customer care, seeking and satisfying customers for life. In many cases, with a detailed definition of the connected network and geography, those lifelong relationships start on a map, allowing a prospective customer to click their location to see what services are available there, or if there are none, to fill out a form requesting consideration. All these self-service requests are captured by the utility or telecommunications company for analysis to understand how well their existing network matches up with where prospective new customers are located, and to plan where new network investments may make sense. The goal, obviously, is more green dots, new customers. Serviceability allows you to support customer requests and improve customer engagement. Then there are real-time updates. Customers always want to know the latest about their status. Today's modern networks are extremely reliable, but on occasion, for planned and unplanned reasons, an outage can occur. At these times, the tracing capabilities of the utility network and the real-time capabilities of the ArcGIS platform enable operations personnel to stay on top of things. Here we're looking at an internal dashboard that continually updates as gas customers move through the relight process after an outage. In the impacted customers panel, you can see the always current number of meters out, off, and restored. The map updates too as each change occurs. This keeps everyone in the gas utility abreast of the latest regarding each customer. And the customers like to see that data for themselves. Public awareness is an important part of customer care. While customer service representatives can pass along to customers the latest information they glean from the internal dashboard map, a gas utility also can prepare a public version of the same real-time data for customers to access themselves on demand. Public maps typically may include basic safety information, as well as various map views at varying levels of detail and search capabilities. With the latest information continually accessible, each customer can decide when they want to check for the latest on their individual status. The utility network and ArcGIS provide capabilities essential to delivering better customer care. Now let's look at capabilities. In the brief time we've had to look at customer care, we've touched on at least 6 capabilities: self-service, network definition, customer locating, tracing, real-time updates, public situational awareness. Customer care can be thought of as the process of a utility or telecommunications company seeking, connecting, serving, and satisfying the needs and expectations of those buying what it delivers. Delivery, of course, is via a network, and satisfying customers in many cases depends upon how well you understand your network. and how and where your customer is connected to it. That's where the utility network comes in. The 8 key elements of the utility network enable you to create a digital model of each and every component in your network at higher fidelity than ever before, and define how those components relate to one another and behave. This model is, of course, what we often refer to as a digital twin. With a digital representation of your assets faithfully mirroring details of your real assets, you can work with your digital network just as you do the real one. At the end of the day, a higher fidelity network model is an enabler of higher customer satisfaction. What we've seen in this customer care segment also highlights tracing. Answering many questions requires that you be able to determine a path directionally based on connectivity or traversability from a specified starting point in your network to a barrier or barriers that bound it. The utility network provides powerful tracing capability through 8 out-of-the-box options, as Matt discussed earlier. We've also seen a glimpse of the role subnetworks play, subnetworks being topological sections of a domain network, like isolation zones in this section's gas utility example. As we know, the business value of capabilities provide benefits that impact KPIs. So let's look at benefits. There are many, including more convenience, better efficiency, deeper understanding, greater timeliness, more transparency, and broad awareness. These lead to positive impacts on KPIs, number of customers, customer satisfaction, retention rate, response time, and regulatory compliance. So with that, Matt, I turn it back to you.
Thank you very much, Tom. And I want to thank all of our industry directors for presenting today. It was a lot of content to get through. There was a lot of little short, sharp demonstrations that we interweave there. But there is one more thing I want to just quickly cover off before we get to the end of the webinar, and that's taking all this information and enabling your business transformation. So something we want to talk about is some of the insights on how the utility network is enabling utilities and telecoms to manage modern assets and their networks in GIS. So if we start by understanding what we spoke about here on the electric side, and we can understand that we move from generation all the way through to transmission, distribution, eventually end up at the customer. And we don't just model that network, we model the modern network that we talked about in one of those polls earlier. And this is understanding the impact of all the solar and distributed energy resources and even microgrids. We can continue that and bring in the gas network. And we start understanding how do we move from the wellhead all the way through to the distribution, and once again, it'll end up at the customer. So the customer becomes the common thread here. Now we bring in the telecom and cable network, and this is from the network carrier into the wireless, and you can see here the fiber network, which is overlaid onto the existing infrastructure electric network. There is a relationship between the infrastructure of the fiber and to the electric network. And you can also see that we've also got some of the advancing technologies such as autonomous vehicles with small cell rollouts of 5G. And finally, we look at the water utility. This is where we start thinking about the new smart water utility, the introduction and aligning between the water utility and the water resources model and how that impacts. What is very common between all these different industries is that they're all looking to do smarter analysis, and the control room and the sensors and all the information is being brought together. This is where the GIS and the way that we bring these data models really come to their own. Turning all of our networks into a smart network, creating that single point of view, that operational view that Patrick spoke about during the presentation. This is where the GIS really comes to its own. So what we may not know is that these aren't 4 different models. This is the one model. This is the one utility network model. And these aren't independent. What I mean there is that if you have a power outage, you can actually trace through and find out, well, what of my water network is impacted by that? What of my telecommunication network is impacted by that? These are actually interrelated models that you can actually trace through and understand what is happening across different industries. So with that, I'm going to move on and talk about when we try and justify enabling this digital transformation, we first need to understand what the utility network is. So the utility network is the next generation technology which is enabling utilities to achieve their digital transformation targets. I hope you saw a lot of the little presentations that we gave today. I know it was a lot of content, but really start thinking about how you position this in your utilities. And we do this by positioning against your business values. Every utility or telecom has these core values, whether we need to be safe, reliable, secure, affordable. We got to have better customer community. We got to be more efficient in our services. And we align that into certain business departments. And GIS is now breaking down those silos and bringing all these departments. GIS is a common thread across all these different departments that we talk through. And then you align that into solving real business initiatives, whether it's emergency management, renewables, grid modernization strategy, the IoT big data, whether it's 5G and telecom. All these different initiatives are real, and the utility network is a key component of as being that enabling technology. So we align it to business values. We apply it across these lines of business, and we understand that how it applies to these strategic initiatives. And what you'll find is the utility network is an underpinning technology that enables this. So with that, we're going to wrap up the webinar, and I want to thank everyone for attending. I hope you found it useful. Please don't forget that we do have our third and final webinar in the series on August 5th, which is the migration and implementation to ArcGIS Utility Network. And with that, we are out of time. Unfortunately, we don't have any time for questions and answers. I have checked, and I know we have a number of questions that have come through. Please, we'll get back to you in a response during a Q&A document following the webinar. So once again, on behalf of my colleagues, thank you very much for your time and have a great day.